The calculation of the last class, we have for the spherical reactor, we have gotten our phi, which is a function of r, to be equal to A sine BR over r. Now, we are still having issue because we've not finished text 1. This B, we are going to get it. So we can discover that, okay, there is nothing. We've had something like this before. That if this thing is going to be, we can actually just say, okay, this B, like before, can be n pi over r. You know, in a slab, the thickness is A. In a spherical, it will be what? R. So we can put our Bn to be equal to n pi over r, which our B1 will now be equal to what? B1 will be what? Pi over what? R. So we can write our critical flux to be phi of r is equal to A sine pi over r over r. Or just leave it like this. Phi r is equal to A sine dr over r. The next one is how are we going to calculate the A? We are going to go through operating power of the reactor. Like you know, this one, the power, like you know, is irrecoverable EF flux. Okay? But this one is a 3D, three-dimensional, and it is finite. So our integration will be volume integration. So phi what? dV. For a spherical, the volume integration, if you are neglecting the two angles, that is the volume integral dV will just be 4 pi r squared dr. So we can put this here to get what we want, which now be P is equal to ER EP A sine BR over r dV, which is P is equal to ER EF A sine BR over r 4 pi r squared dr. One of them will cut each other out. P is equal to 4 pi. 4 pi is out. A ER EF R sine BR dr. Right? Yes. So let's solve this one. And where will this one go from? What will be the boundary condition? 0 to r. Calculate this integration now. So using the integration by part method, our u still remain r. Our dv is sine dr. So this one will now be r minus 1 over b cos dr minus 1 over b cos dr. Du is 1 dr. This is minus r over b cos dr plus 1 over b cos dr dr. When we solve this one, we have minus r over b cos BR plus 1 over B squared sine BR. So this one will be, this one we can have it to be, let's take 1B, 1 over B out.
So should not be minus? No, not minus.
1 over B sine BR minus R cos BR 0 R. You know that our B is pi over half. Now B R over pi, yes, R over pi sine pi over r dot r, at we are evaluating at r, minus r cos pi over r minus at 0 r over pi, this one will be 0 minus at this one 0 also, so we don't need this one, we stop at this one. So this one will now give us okay, now have r over pi sine pi minus r cos pi. Okay, now this one is 0. Am I right? Now r over pi minus cos pi is minus 1 minus r minus 1. Now what? Half. Am I right? So entire here will now be what? Half. So this now will now give what?
R square.
R squared over what?
Pi.
Over pi. So we can go back and put it here. Now P is equal to 4 pi A E R E F R squared over pi. Pi will cancel pi. My head will just be P over what? 4 E R E F R squared. So my flux now will not be what? P over what? 4 E R E F R squared sine D 1 R over what? Thank you.